Hello, everyone. I'm Meyer Gutbrod from the University of South Carolina, and today I'm going to talk to you about redefining right whale seasonal habitat use under a new climate regime. This work was done with a large group of collaborators, all of which had an important role in the project. This work was motivated by our previous study examining shifts in the physical oceanography in and around the Gulf of Maine. Changes in the position of the Gulf Stream and subsequent warming in the basins are correlated with a decline in Calanus finmarchicus in the previous decade, which has been associated with declines in right whale reproduction and, of course, shifts in their distribution. If you're interested, please feel free to see the paper that we published in Oceanography last fall. For this study, we broke right whale habitat use into distinct polygons, ranging as far north as the Gulf of St. Lawrence and as far south as the southeast U.S. calving ground off the coast of Florida and Georgia. Then we built models to examine changes in right whale sightings per unit effort, as well as changes in Calanus availability for each distinct polygon in each month. And we compared sightings per unit effort between the 90s and 2000s. And we also compared sightings per unit effort between the 2000s and 2010s for each polygon in each month. Today, we're only going to focus on the results of the comparison between the 2000s and the 2010s. This is an example of the data that we used in this study. So we're looking at two maps of sightings, right whale sightings per unit effort. On the left, that's for the decade of the 2000s, and on the right, it's for the decade of the 2010s. And for these maps, we're looking at the months of April, May, and June aggregated together. So the X's denote areas where there was effort at some point during these months within that decade. And the colored dots are the size of right whale sightings per unit effort. So the obvious trends we can see for this spring season between these two decades is there's no effort and no sightings in the Gulf of St. Lawrence in the 2000s. And of course, in the 2010s, we both have sightings. We have effort as well as right whale sightings. There's also an increase in the most recent decade in right whale sightings in southern New England, right just south of Cape Cod Bay here. Another interesting thing is there is an increase in the use of Cape Cod Bay and Massachusetts Bay this decade relative to the previous decade in the 2000s. And of course, Bay of Fundy use was higher at this time in the 2000s than it is now in the 2010s. So we built a distinct Poisson model for every single polygon and every single month to ask the question, has right whale sightings per unit effort changed between this decade and the last? We compared the 1990s with the 2000s, but I won't be talking about that in this talk today. Today I'm going to focus on the comparison between the 2000s and the 2010s. This heat map here on the left shows the results of each of those models. On the y-axis, we have the polygon that was tested, so starting at the top with southern Gulf of St. Lawrence, Bay of Fundy, Roseway Basin, Jeffreys Ledge, and then across the x-axis we have the month, so January, February, March, etc. The color of each box tells us whether or not sightings per unit effort was higher in the 2000s, which are the blue boxes, or higher in the 2010s, which are the red boxes. Some interesting patterns stand out, of course, in the Bay of Fundy in August, September, October, November. When we have effort, we can see that there were more right whales using the Bay of Fundy and Roseway Basin habitats in the 2000s than in the 2010s. Then down here in the spring in the Cape Cod Bay, Massachusetts Bay area, we see the opposite pattern, where right whales are using the Cape Cod Bay habitat in higher densities and longer throughout that spring season in the 2010s relative to the 2000s. This is probably driven, it's harder to see here because of the relative amount of sightings we'd see in the calving ground, the southeast U.S. polygon, but there were fewer animals using the calving ground during the 2010s as births declined. And so some of those animals may have been using the Cape Cod Bay instead of migrating south. There's some frustration in that we can't really run this model for the Gulf of St. Lawrence because effort was almost negligible in the decade of the 2000s. So although we have this sense that animals are using the Gulf of St. Lawrence much more in the 2010s, we couldn't use this model to show it quantitatively. Although we had limited effort in the Gulf of St. Lawrence in the 2000s, we did look at data from the Mingan Island Cetacean Study, which has been running with high survey effort for the past 40 years, looking for rorquals in the northern Gulf of St. Lawrence. And they have seen very few right whales during their surveys, a few towards the end of the 90s and the start of the 2000s, which interestingly correspond to another decline in prey availability. But then starting mid the previous decade, 2014, 15, especially in 2016, this study began to see right whales even this far north in the Gulf of St. Lawrence, and they've seen right whales every year since. We paired our right whale sightings per unit effort data with Calanus data collected by the Ecomon surveys in the Gulf of Maine and a bit on the Scotian Shelf. Those are shown in black here. And AZMP surveys conducted by the DFO shown in red here. For the AZMP surveys, we looked at both Calanus finmarchicus as well as Calanus hyperboreus. This heat map shows the same kinds of models. Poisson models run looking at Calanus counts per polygon per quarter. I've grouped them into quarter to make it a little bit more digestible. And so here on the right-hand side, we can see that heat map of model results from the 2000s minus the 2010s. Again, blue boxes mean more Calanus in the 2000s, and red boxes mean more Calanus in the 2010s. And of course, we see just overall a decline in Calanus throughout the area, except for in Q2 in the spring months in a few key places, including Cape Cod Bay and Jeffreys Ledge. We also looked at these 4 AZMP stations, Prince 5 in the Bay of Fundy, Halifax 2 on the Scotian Shelf, Shadiac Valley in the Gulf of St. Lawrence, and Rimouski. And we compared Calanus finmarchicus and Calanus hyperboreus between the previous 2 subsequent decades. Again, all these blue boxes indicate that Calanus was higher in the 2000s than in the 2010s. That's true for finmarchicus and true for hyperboreus, except for at the Rimouski station. So now if we look at our model results from our Calanus finmarchicus data, as well as our right whale sightings per unit effort data, we can see that right whales using the Cape Cod Bay and Massachusetts Bay area for in higher density and for a longer portion of the season in this recent decade may be at least partially driven by an increase in prey availability in those areas at this time. The decline in right whale habitat use in the Bay of Fundy and Roseway Basin in the late summer and fall is most likely driven by a corresponding decline in Calanus finmarchicus availability in those regions during that season in the 2010s relative to the 2000s. We think it's important to note that right whales are, when they shifted from the Bay of Fundy to the Gulf of St. Lawrence, they are shifting away from low prey availability rather than shifting towards high prey availability. So Calanus finmarchicus declined in Shadiac Valley in this most recent decade as well. There's a lot more nuance that we could get into with these data and these model results, but of course we're tight on time. But I would encourage you to take a look at this paper. It should come out within the next few weeks in Limnology and Oceanography. Thanks, of course, to our collaborators, to the consortium, and to NOAA and the DFO for data curation, and to LenFest for funding this study.